Hi, hello, this is your Sir. Today I am going to discuss NEET previous year solved papers since 2009 to 19 10 years papers. So we'll see here the questions one by one since 2009. In 2009, there is a question like this: the electric field at a point x, y, z is given by v is equal to minus x square y minus x z cube plus 4. The electric field at that point is, and options will be like this: 2x I cap and x square plus j y square j cap plus 2x z by minus y square k cap, and see the second option, third option, and fourth option. Let it be. So I'll tell you how to solve these kind of problems easily. So there is a formula like this. That's what E is equal to EXI cap plus EY j cap plus EZ k cap. And if you want to find any one of the coordinate like this, EX is equal to minus dV by dx. So you just differentiate above equation with respect to x, then you will get E along the x coordinate. So when you differentiate this, okay, differentiation of x square, that will be, there is a minus here, minus, and differentiation of x square minus 2x and into y, and there is a minus here, so minus as it is, and differentiation of differentiation of x will be 1 and remaining, so z cube, and differentiation of 4 will be 0, therefore remaining, so it's a minus of minus 2xy minus z cube I cap. When you take minus outside or x common, remaining 2xy plus z cube I cap. So along the unit vector I cap, is there any option like this? 2xy plus z cube. We just search first option. So only 2xy is there here, only z cube is there here, 2xy minus is there here, plus is there. So that next let's go for next option. So it's in 2xy plus z cube I cap is so it's a matching, so therefore need not to solve remaining factors, easily you can get the answer. Next, when you come for 2010 question, so two positive ions each carries a charge q are separated by a distance d. So if F is the force of repulsion between the ions, the number of electrons missing from each ion will be, so that here there are uh, two ions carrying a charge q. Okay, they're separated by a distance at d. In such cases, we need to find, so number of electrons are missing. Is a direct and very simple question. That's what we can use the direct formula. So it's a 1 by 4 pi epsilon 0 and q square. Instead of a q, I can directly write ne square, so divided by, it is a d square. So then if you want to find n here, so n e square, just to simplify, so I am bringing all the factors into left hand side. That's what, so 4 pi epsilon 0 f d square. So if you want to know what is an ne, ne means you just take a square root on both sides. Ne is equal to square root of 4 pi epsilon 0 f d square. So what do you want to hear? We need to know number of electrons are missing, n value. So therefore n is equal to square root of 4 pi epsilon 0 f d square divided by e. Is there any option like this? Okay, it is not. So it is not. Okay, so I think, yeah, it should not be, and then the right answer will be C. especially for this question. So next we'll go for next all over India pre-medical test question or NEET level question. So in 2010 again there is one question here. So a square surface of side L meter in a plane of paper is placed in a uniform electric field E and acting along the same plane at an angle theta with the horizontal side of a square as shown in the figure. Okay, so then find the flux linked with the surface. So here you should remember the flux enter, which is taken as a negative, and the net flux is leaving the surface. So leaving the surface, which is taken as a positive, but magnitude of the flux which is entered the surface and leaving the surface same, and hence the net flux will be 0. Therefore right option will be in this, right option will be 0. Next we will go for next question. The electric potential at any point x comma y in the space is given by v is equal to x square. Electric field at the point 1 comma 0 comma 2 in a volt per meter is okay. So already we have discussed it in earlier case. The same method is appearing here. So to find the electric field intensity, that's what Ex, only one coordinate, Ex I cap. To find Ex, what we need to go? So we need to differentiate V with respect to Ex. Therefore E is equal to minus differentiation of x square. It is 4 to 8. 8 into x I cap, and know the positions 1 comma 0 comma 2. So it means x coordinate, y coordinate and z coordinate. The x value will be 1. So therefore E is equal to minus 8. In which direction? Unit vector I cap. It means along the negative x direction. Negative x direction. Is that an option? 8 along negative x direction. 8 along positive x direction. 16. So right answer is 8 along the negative x direction. Simple now. So this is the easiest way to find solution for that question. Now let's see the one more question is in 2011. That's what 3 charges each q are placed at the corners of is a corners of an isosceles triangles ABC of side AB and AC is 2A, and D and capital E are the midpoints of BC and CA. The work done in taking a charge Q from D to E. Now see here. So here there is a charge Q. Here there is a charge Q. Here there is a charge Q, and all the distance between BC is the same distance between AB, same distance between AC is same, and if you take a midpoint from here to here, I can take it as an A, and even from here to here I can take it as an A. So charge is same, distance is same, then therefore the potential will be V here. Even the charge is same, distance will be same, the potential will be same here. When you take the potential difference between D and E, that's what the potential difference that will be 0. Therefore the work done will be, that's what, q into delta v. So since delta v is 0, the work done is 0. The right answer is, so this one. So next, we'll go for the next question. Again, there is one more question in 2011. A charge capital Q is enclosed by a Gaussian surface of radius r. If the radius is doubled, then the fields are outward. Electric flux will be, okay. So this is the case. There is a spherical surface. There is a spherical surface here, like this. Spherical surface, the field lines will be radially outward like this, okay. So even if you place a charge inside the sphere, it means the charge has been enclosed at the Gaussian sphere. So according to statement, what it will tell is the net flux over any closed surface, so it is always yeah, equal to q by epsilon 0. It doesn't depends upon any dimension. Therefore, even if you increase the radius or some other dimensions, the flux over any closed surface never change. Therefore, the right option will be here. So remain same. So next, one more question in a 2012. They asked one more question in a NEET exam or all over India pre-medical test. The two metallic spheres of radii 1 centimeter and 3 centimeters are given charges minus 1 into 10 to the power of minus 2 coulomb and 5 into 10 to the power of minus 2 coulomb respectively. If these are connected by a conducting wire, the final charge on the bigger sphere, okay. When there are two spheres, one is in 1 centimeter radii, another one is 3 centimeter radii, and on each sphere, on smaller one minus 1 into 10 to the power of minus 2 coulomb, and another on another one will be, so 5 into 10 to the power of minus 2 coulomb charges are there. So it's only thing, suppose we are connecting and conducting wire between these two spheres, 100% it maintains an equipotential surface and the charges will changes. What will be the charge on each sphere? Especially here the question is what may be the charge on bigger sphere. To find that one, there is a formula here, so I will give a very shortcut formula. That's what to find on bigger sphere. So that's what a QB and net charge and radius of a bigger sphere, I will take it as an R2, and it's divided by sum of the radius. It's what, R1 plus R2. So therefore it's a charge on the bigger sphere, that is equal to net charge, so minus 1 plus 5, total the 4 into 10 to the power of minus 2 into, so R2 value, so what is the R2? It's in 3, so 3 centimeter, so that 3 into 10 to the power of minus 2, it's divided by, so net it means R1 plus R2, 1 plus 3, it is 4 into 10 to the power of minus 2. So yes, so 4 will get cancelled, and 10 to the power of minus 2, 10 to the power of minus 2 will get cancelled, remaining 3 into 10 to the power of minus 2 coulomb. Is there any answer here? This is the right answer, 3 into 10 to the power of minus 2 coulomb. Okay, so already I have told you that. So yeah, if you are having any doubt or if you want to discuss anything else with me, you can WhatsApp me or even having any challenge, you can WhatsApp me for this number 7892186108. Okay, let's continue the discussion in next section. Thank you.